Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
So we've all seen magnets, fridge magnets, giant crane magnets in junkyards, toy magnets that we play at home with, and they're all cool. Yeah, but here's what most people don't realize: that little magnetic force that keeps the fridge magnet on the fridge, it's actually relativity at work, like the Einstein level relativity.
Yeah, the same Einstein who made time dilation and E is equal to mc squared famous. He's the reason your fridge door doesn't swing open when you walk past it.
And that sounds completely ridiculous at first, right? I mean, Pratham saying it, so it has to be ridiculous.
Bro.
Kidding. So, I mean, you wouldn't think your boring copper wire or the magnet that you used in science class was screaming about, hey, I'm related to special relativity.
But it is, because the magnetic force, what we call magnetism, is really just an electric force seen from a different frame of reference.
Yeah, it's all about perspectives. TOK is still on top, coming like it's clinging on top.
Don't.
Yeah, okay,
And
fine. Let's avoid that.
If you're already like, I need 3 coffees to understand what you just said, don't worry. We're breaking this down. And yes, there will be cats,
Not Schrodinger's cat.
not Schrodinger's cat,
Yeah.
and probably a questionable joke about electrons.
All right, let's start simple. Picture a copper wire, and inside it, you've got a bunch of stationary positive metal ions just chilling, like dad's at a barbecue or Pratham's at anywhere.
Hey.
Now, surrounding those are the wild little negative electrons zipping around like kids on sugar. They're the ones doing all the work, per se. It's not child labor, but it is child labor, kind of like in our analogy.
Oh my god. Basically, when there's no current, these positives and negatives cancel out.
So, like the adults and the children on sugar cancel out.
Yeah, the total charge is neutral. Your wire is basically Switzerland. Now let's pass a current through Switzerland. I mean, your wire.
Yeah.
That just means the electrons start drifting in one direction. Super slowly, by the way. Like grandma with Wi-Fi slow. Still, even with the current, the number of positive and negative charges is still the same. So if you bring a charged particle, say a positively charged cat near the
Like
wire,
like basically like rubbing around a fur coat or like a very furry cat, and that cat is positively charged.
yeah,
If
yeah,
you bring that near the wire, then the cat won't feel anything.
yeah, there's still neutral overall, right?
Yeah, the wire is still neutral overall. Yeah,
Yeah.
there's no force on the cat.
Yeah, and nothing shocking is happening just yet. It's just normal physics.
But here's where it gets juicy. Let's say the cat starts moving. Okay, it's strolling around along the nice street. Okay, and it's not in just any direction, but along the wire at the same speed as the electrons. So if the cat and the electrons are moving in the same direction at the same velocity, in our frame of reference, things still look the same. The electrons are drifting, the positives are fixed, and the wire is still neutral. So we're like, cool, cat's still moving, still no force, right?
Uh, Wrong, because from the cat's frame of reference, the game changes. Now the electrons appear stationary to the cat. They're not moving relative to it anymore.
Yeah, because if they're moving at the same velocity as the cat, exactly.
Yeah, but the positive ions, they are moving now, and according to special relativity, moving objects contract. That means these positive ions look like they're squished closer together.
And the technical term for that is length contraction.
Yeah. So now there's more positive charge packed into the same space, basically higher charge density.
Yeah.
The wire suddenly looks positively charged now.
And what happens when as we said earlier, the cat was positively charged. What happens when a positively charged cat sees a positively charged wire?
Exactly, repulsion.
Yeah.
Right?
So the cat gets pushed away, not by magic, not by magnets, but an electric field that only exists in the cat's frame. And that's the key. The force is same in our frame and the cat's frame, but in one frame it's called magnetism, and in the other it's just electric repulsion caused by length contraction. That's it. So magnetism is just electricity seen sideways.
Yeah, it's like saying your ex wasn't toxic. They were just operating in a different reference frame. And that's not just some philosophical mumbo jumbo, that's real testable physics.
And yes, we know what you're thinking. Wait, did you say long ago, like it was a while ago, you said that electrons move slowly, but relativity still clicks in. Like you said, the grandma Wi-Fi kind of thing, right?
Yeah.
But that's true. Even though the electrons drift at like 0.000000001% the speed of light, there are so many of them. And the electric force is so strong that tiny amount of length contraction still matters. It's not negligible.
Yeah, it's the same reason your microwave works, your electric guitar sounds cool, and your MRI machines don't explode.
It's
It-
all about electromagnetism, right?
yeah, and underneath that, it's special relativity. It's like finding out your toaster runs on quantum field theory.
Yeah, it kind of does. It's kind of humbling and kind of terrifying at the same time, right?
Yeah,
Now, that's the story for electromagnets, current carrying wires. But what about the OGs, like the real deal, permanent magnets, those chunky metal things that cling to your fridge or mess with compasses without any external help per se?
the black magic of the magnet world. It turns out even they owe their powers to moving charges. Inside atoms, electrons are spinning, and when enough of them spin in the same direction, the atom becomes a tiny magnet. Get enough of those aligned, and boom, you have a permanent magnet now.
So even though the electrons aren't zipping through wires, they are moving within atoms. It's like a universe and within a universe within a universe kind of thing, where
Yeah,
each electron's doing a tiny dance, and when the whole material starts grooving and vibing together, we get magnetism. And electrons are basically like the chota packet bada dhamaka kind of thing, whether the together it's like ape together strong.
yeah.
Electrons together get a lot of energy. Tiny dancers giving a lot of energy.
And what's powering that whole show? You guessed it. Special relativity again. Because even those atomic spin effects can be explained in part by relativistic corrections to quantum mechanics. Honestly, it's like Einstein left secret Easter eggs all over physics.
Bro, Einstein's a Easter bunny leaving all the Easter eggs. So the next time you see a magnet sticking to your fridge, just remember that's not a chunk of metal. It's a relativistic miracle. Sticking your leftover grocery list to the surface of your kitchen appliances, aka refrigerator. But yeah.
Yeah, and if someone asks how do magnets work, you don't need to panic or say it's complicated. Just say in my frame of reference it's electricity and then walk away dramatically.
Yeah, fair. So, okay, fine. We cracked the case of electromagnets, wires, current, cats, and relativity. But now we are in deeper waters. We spoke about permanent magnets.
Yeah.
Let's talk more specifically about permanent magnets, the kind that doesn't need a battery or a coil, just pure passive magnetism. How is that possible?
I mean, there aren't any obvious electric currents zipping around inside a chunk of iron, right?
Yeah, right. You don't just plug in a fridge magnet, right? You stick it on and it clings there like it's got something to prove. It's like the power. But here's a secret. Even though electrons in a permanent magnet aren't moving through wires, they're still in motion, as you said. And inside atoms, electrons orbit nuclei and also have a property called spin, as you said. And it's not them like literally spinning like ballerinas or like a basketball Steph Curry.
Steph Curry goat.
It's
Continue.
quantum spin. It's weirder, it's cooler, it's a bit crazy.
Yeah, in quantum mechanics, spin isn't physical spinning, it's more like the electron's personal vibe that somehow creates a magnetic field. Like, think of it like tiny magnetic fidget spinners.
That don't spin.
Yeah, each one generating a micromagnetic field. Now, usually in regular materials, all those spins point randomly in different directions, canceling each other out. The result, no magnetism.
But if you take those randomly aligned different directional spins and align them with an external magnet, with magnetic materials like iron, cobalt, or nickel, something different happens because of the same alignment. They all are aligned in one direction, and the net charge doesn't cancel out. And electrons in nearby atoms actually align their spins. And when a large region of atoms align together, we call those magnetic domains. It's like entire neighborhoods of electrons going, okay, guys, we're all pointing this way, we're all spinning this way, and suddenly the whole that part or that entire thing becomes magnetic.
The funny thing is that this alignment happens naturally, and when the domain lines up in the same direction across a region of metal, you've got yourself a magnet. Permanent magnets are just metals with extremely bossy electrons that won't stop pointing in the same way, which honestly sounds like some teachers we've had. And
Allegations.
and maybe
Deep allegations.
maybe student council members. I'm not saying
Edward
anything.
Witten. So now you might be wondering, how does this connect to relativity again? Well, quantum spin alone doesn't fully explain the strength of magnetism. You need relativistic corrections, as we said earlier,
Yeah.
to get the right values in quantum models. Basically, when electrons move closer to the speed of light inside atoms, relativity steps in and say like, hey, wait a second, I have notes.
Exactly. If you don't account for special relativity, your math starts giving you wrong answers. So yes, even if your childhood fridge magnet is a collaborative project between quantum mechanics and special relativity,
That's going to be a good physics EE.
it's like Einstein and Schrodinger are co-parenting your kitchen door.
And don't forget materials like magnetite, which naturally occur in rocks. So, like some of the earliest compasses used magnetite, literally rocks that knew where north was, like sentient rocks, not
Yeah.
really, but yeah. And ancient humans must have been like, this rock points, witchcraft, but nope, physics.
And guess what? Even birds use this stuff. They've got magnetic sensors in their brains, magnetite crystals that help them navigate the Earth's magnetic field, which basically means pigeons are walking flying physics experiments with GPS built in.
Yeah, magnetite sensors, really? So, between magnetic materials, electron spins, and the subtle whispers of Einstein's Easter Bunny equations, we get the permanent magnet. No moving parts, no batteries, just quiet, stubborn physics doing its thing in the background.
To sum it up, electromagnets show us that magnetism is electricity seen through relativity, and permanent magnets they show us that aligned quantum spins plus relativistic corrections can build entire machines, motors, and magnetic poetry sets.
And whether it's a wire wrapped around a nail or a chunk of magnetite helping a bird migrate, relativity is always lurking in the background, quietly rewriting the rules of what we think is just magnetism.
So yeah, next time someone says it's just a magnet, feel free to say actually it's a quantum relativistic phenomenon arising from the flame dependent asymmetries in charge density due to the length contraction and spin orbit coupling.
Then pause for dramatic effect and sip your tea.
Or
Or
bet-
better yet, just throw the magnet at them and whisper, Easter Bunny, Einstein says hi.
All right, that's enough electromagnetic wizardry for today.
Until then, stay attractive or repulsive, depends on
Depends
your
on your
charge.
charge.